Okay, so down here it got a little tabbed over, but we are going to prove the derivative of e to the x using natural log, and then we're going to prove natural log using e to the x. So this assumes that this is accurate. Assuming that this is true, can we prove this? Okay? So this should be over here, I'm sorry the layout's a little funky, but let's give it a whirl, see how we do. So, if we are finding the derivative of e to the x, and we're using this is what we start with. So what did we say the derivative of natural log was? We said that it was 1 over x. So the derivative with respect to x of the natural log of x equals 1 over x. How can we prove the derivative of e to the x? What do you think first steps are going to be?
Can you put e to the x in natural log form?
Yeah. So we can take the natural log of e to the x and say, we know that this equals x. Can we take the derivative of both sides? Sure. Take the derivative of both sides. Remember, that's an operation. So we know that the derivative of the natural log of something is going to equal 1 over that something times the derivative of the inside. And that all is going to equal 1. How are we feeling so far? You catch my chain rule on the left?
Yeah. How did you get the dx x?
So if I do the derivative of f of x, I get f prime of x. Oh, I'm sorry, f of g of x. I get f prime of g of x times g prime of x. So this is chain rule. And this is the inside of the chain, so I have to take the derivative of it. I knew that the derivative of natural log was 1 over the inside. I don't know what the derivative of the inside is, so I left it alone the way it was. Okay, so now I can solve for d dx. I'm erasing that because that's actually what we had up above. It was just copied over again. So now I can say that d dx of e to the x equals e to the x. Ta-da! How'd you feel about that? We don't need to know the proofs, but do you see the logic of how we are applying the derivative as an operation? Yeah? Okay, we'll go a little quicker with the other one. So the derivative of natural log is 1 over x, and now we're going to start with e to the x. So if I started with natural log of e to the x, oh no, wait, stand by, I did that backwards. Where's my eraser? If I'm starting with e to the natural log of x, and we know that that equals x. If I apply the derivative on both sides, take the derivative on both sides, perform the operation. The derivative of e to the x is e to the x, but then we have to do the derivative of the inside. My natural log got funky. Let me fix it. And the derivative of x equals 1. E to the natural log of x is just x. Divide both sides. So dy. Oh, I'm sorry, not dy. This is why I'm going crazy. This is the operation, not dy. The derivative of natural log. Sorry, guys. I'm feeling quite discombobulated today. So the derivative of the natural log of x equals 1 over x. Now, these weren't really true proofs because we assumed that one was true and proved the other, right? So, like, that's kind of not exactly kosher. Not supposed to do it that way. But do you understand the process? Do you understand the operations? When Mrs. O'Connor's not making mistakes, do you understand how we're using ddx? I hope. Questions? Yes. Sorry.
Natural log of x get you the exponent.
I started with this. And I said, I already know that this equals x. Would you agree?
How does that work?
So e to the natural log of x is saying e to the power that gives you x. Because natural log is saying, I want to know the power that I raise e to get x as an answer. And an e to a natural log as the power cancel out. Natural log of e cancels out. So those are our log rules. Okay? Okay. So like back here. Natural log of e to the x is x. E to the natural log of x is x. Those are things we know from algebra 2. So using that and then taking the derivative, I can show why the derivative equals that. Okay. So now let's practice doing some derivatives. Right here in the notes, let's see. These 6 problems, we have the skills to do this using what we know about power rule, chain rule, sine, cosine, tangent derivatives, and now natural log and derivatives of e. So I want to set a timer, 6 questions. I'm going to give you guys 8 minutes, 10 minutes. I'm going to set a timer. I want you guys to try this 10 minutes with your teammates, okay? What? What about it? Yeah, these were like the ones in the Delta Math if you tried the Delta Math. And we will regroup in 10 minutes and look at correct answers, okay? Okay, timer's being set.
was so lost.
Hey, found my answer keys. Okay. Whew. Sorry, you guys.
Because if you're saying that it's u, sine x would
Oh
have to
boy,
be
this
dx.
F one is really long.
If exponent is u, then it would have to go to the
I'm gonna change it to
no, for a.
3x to 1.
I just took this formula that's right here. For e to the u. I just got e to the sine x to e sine huh?
Do 1/2
Yeah, we know that.
sine 2 times 1.
I would do the derivative of x.
Oh man.
Oh, okay. D sine
Yes.
Plus
Can I ask you questions, or do you want to just like
You can ask me questions now if you want to. We will go over it as a class in a second.
Oh boy, this is
Okay.
That's just what happens when you actually do the homework.
Yeah.
You actually understand what's going on, kind of. But okay, for oh, hello. So for this, would we break it down to like this and then do the?
You can. That's one way. Or you can do chain rule and do natural log and then chain the inside.
Okay, and then change.
I don't like
product rule
doing.
in a quotient.
The
I hate quotient rule personally.
same.
So I always would switch it to this.
Okay.
Personally.
Yeah.
So this
Are you
But,
switching
like-
it into
That's-
subtraction
it's
problem?
2x minus 1 to the third times 5.
Well,
Yeah, so you can
Oh, well,
so
yeah.
expand the log.
But
So
there's a
it's
product
natural
rule
log of
inside
x
quotient.
minus 2 minus natural log of 3x plus 1.
Yeah, exactly.
Both ways are
Oh
correct.
my gosh. Killer, this is killer. Okay, wait, so I can do the derivative.
And the derivative of
Derivative
these
of that.
things.
Oh my gosh, this is crazy. I went to here. I guess you could have multiplied the top one by the. Wait, how did you get 7?
What's the numerator?
Oh, because quotient rule. you have to
Yeah,
divide.
natural log of x minus 2.
My bad. I didn't even do the quotient rule, right? I didn't even
Times
subtract.
1.
I did
That's the
one.
derivative. We don't need to do that. Okay.
And then it's all over here because it's one squared. I don't think I'd go too deep into it. This is good. These are out.
I did the homework. I don't know what I'm doing.
I just the thing is though, like I
This ends up as 3 over 3x. Right? Or did you get 7? I got 3.
It helps.
Oh, it is 6. My bad, my bad. Yeah. So it's 7.
Oh god, there's a typo on number 4 on letter D. Stand by, stand. Were you guys all like, "Yay, this one's easy"? Sorry, fake news.
I knew it. It's a log based something. Isn't it?
Oh, what the heck does that mean?
You know, I'm trying to do D dot.
I mean, you should be able to do the other one super fast too, but that one was a typo. Sorry.
Forgot how the log one works. Log.
Log of x.
So it's 1 over x times. Oh, 3. So it's 1 over x times. I'm just gonna leave this out.
That looks like a good answer.
I'm lazy.
mean, the thing is that this isn't even what the free response questions are going to be like,
Yeah, I know. This is more multiple choice.
right?
I'm gonna do.
Alright,
Yeah,
how many more
just
questions
that.
for pricing?
Is this page helpful? Don't care. But I think so. Okay. 45 multiple choice questions. And then 6 FRQs. Part A and part B. So B, I love when the part B is 60% of the score, and that's the part we get to use a calculator on. Hooray. Anyway, back to this.
What? Set? Oh.
Yeah, I don't know how. I don't know if I did this right, but I'm gonna say I did. Oh, I did this. I just left it as a exponent because I didn't want to have to root it all the time, and then I was gonna simplify it after. I think it's easier, but
Break this whole thing down.
I'm just gonna like.
Okay.
I'm not.
We're
simplifying
probably
this.
not done, but some of these are a little spicy, so we're gonna start looking at them together. That was our 10-minute mark. Okay, so these all had chain or quotient or something else going on with them. So good review of the stuff we were looking at the last unit too. So first one, this is a chain rule. The derivative of e is e to the x, copy it down exactly. Then the derivative of what's on the inside, the derivative of sine is cosine. Okay with that one?
Yep.
Okay, next one. So this one was another chain rule, but because it's not e to the power, it's 3 to the power, we had to include this rule. So remember, if we had the base a to the x and we took the derivative, the rule for this one is a to the x times the natural log of a. So I'm having to do that and then chain. So the first part, so 3, that part is identical to what we started with, right? That matched. And then the natural log of the base. So that was my my exponential rule for derivatives. And then it's a triple chain. So the derivative of cosine is negative sine, and the derivative of the inside is 2. Triple chain.
Does it matter which way you wrote it for like?
No, commutative property applies to multiplication, so I could have written these things in any order. The only thing I will say is that I would make sure for sure the negative was off in the front. Negative, constants, first thing, all the other expressions, doesn't really matter. Grace.
Where do you get natural log of 3?
So this is the rule right here. So if I had the derivative of 3 to the x, the answer would be 3 to the x times the natural log of 3.
Okay.
But I didn't have that. I had the cosine, and that's why I had to chain off to the side. Okay, let's look at this one. This one made me happy. I was like, oh, you're easy. It's a little bit of work, though. So the natural log, so the derivative of the natural log of x is 1 over x. So I just replaced that. That was the first part. And then I did have to chain, but it was a nice power rule, 2x plus 3, and that's my answer, and it made me happy. Did it make anyone else happy?
Yes.
Okay, the next one had 2 choices. So this becomes a question of how does your personal brain work? I noticed that x to the 1/2, I can pull that exponent in front of my logs. So when you start doing derivatives of logs, you need to remember your log properties. And if you don't, I would go into Khan Academy and I would take the log chapter test from Algebra 2. I would go find the chapter on logs, I would take the chapter test, and I would redo any of the stuff it tells you did wrong. I would go review those questions. It's the kind of thing where like the stuff you remember, it's easy, you don't need to do practice. But the stuff you forgot, you need to go try some of it and make sure you remember. Anyways, if I pull down this square root and I put it in front, 1/2, now I can just do the log rule. So the 1/2 is off in the front, and this is just the log rule of derivatives. 1 over x times 1 over the natural log of the base. I like that way. But maybe you wanted to do chain rule. Maybe you're feeling extra spicy. If you want to do chain rule, so this is the log rule, 1 over whatever's on the inside times the natural log of the base. Then I had to chain, what's the derivative of the square root of x? 1 over 2 root x. By the way, this shows up so many times. So the derivative of the square root of x is 1 over 2 root x. It's worth memorizing. Like, I legit might put that on my flashcards because it shows up all the time, and being able to spit it out fast will save you some hassle. Okay, questions on those 2? We're good? Okay, this one also had 2 different ways. If you like quotient rule, Godspeed. If you don't like quotient rule like me, I changed it into a subtraction, and that made my life a lot easier because now natural log is 1 over x times the derivative of the inside 1 minus the derivative of natural log is 1 over the inside times the derivative of the inside, and I end up with 1 over x minus 2 minus 3 over 3x plus 1. Technically, this is legal. I can leave it the way it is. But if I want to make sure that it matches a multiple choice question, I might want to combine those into a single fraction. But I don't have to. So unless I have to, I'm leaving it. Okay. Same thing with this one. Like, do you want to do quotient rule on that? Nah. Especially because this is going to be like a quadruple chain. You've got a fraction. In the numerator of the fraction, you have a square root. And inside of that, you have a product. That's 3 chains. In the denominator, you have a cube and a polynomial. That's another 2 chains. And then you have the product. We're going on like 7 chain rules in there. That's a hot mess. I'm going to split this up. I'm going to split this up using what I know about natural logs, and then I'm going to do each of the natural logs individually. So I'm not taking any derivatives. I'm just splitting things up. I have the natural log of 3x to the 1/2 minus the natural log of 2x minus 1 to the 3rd. 5x is also in the denominator, minus the natural log of 5x. Are you okay that I distributed that negative?
Why is it minus the natural log of 5x?
Because it's in the denominator. So numerator, denominator, minus, denominator, minus.
Wouldn't it just be 1 log with 2x minus 1 to the 3rd times 5x combined?
If you want to, but then I'm doing an extra step. Watch this.
Because isn't the rule that if you want to multiply what's inside, you have to add them together?
So what's the rule for natural log if two things are being multiplied? You can split them by addition. The only tricky part now is that when I split them by addition, now I'm going to have to distribute the negative. So this is minus natural log of 2x minus 1 cubed plus natural log of 5x. And then I distribute the negative. You can do that. If you want to show all these steps, you can do that. I've always remembered that all the things being multiplied in the denominator, they're just all minus natural logs or minus logs when I split them all up in my addition and subtraction rules. Again, do we need to spend some time on logs? Maybe. Okay, so now I'm just going to use, first I'm going to pull down my exponents. Then I'm going to use my natural logs. So y equals 1/2 natural log of 3x minus 3 natural log of 2x minus 1 minus 5x. Oh, no, sorry, natural log. Natural log. Okay, now I'm just going to do my derivative rules. So dy dx equals 1/2. The derivative of natural log is 1 over the inside times the derivative of the inside, which is 3, minus 3 times 1 over 2x minus 1 times the derivative of the inside, which is 2, minus 1 over 5x times the derivative of the inside, which is 5. Let's simplify these a little bit. So I have 3 over 3 cancels, 1 over 2x, minus 6 over 2x minus 1, minus 1 over x. And again, we can leave it like that. We don't have to combine all this stuff unless it's a multiple choice test and I have to figure out because I can see that they're all combined. The properties of logs will save you. That was an awful derivative to do using natural log chain. Not so bad once we spread it all out and expanded our log. Okay.
Wait, can you go back to the
Which one?
bottom left?
Bottom left, blue. Time check. Is this the class where the lunch bell rings in the halfway mark?
No.
Yeah. We're going to do one more little bit in the notes. We're going to take a break for an activity, and then we will finish the logarithmic notes after, but we have to pay really close attention to the time. So let's see. This bell for lunch rings at what? 12:40.
Oh yeah.
I can't even tell what's going on with this nonsense. 12:40. Okay, so we're in good shape. Are you guys okay for this last little bit of notes?
Let's do it.
Compare and contrast. These are 3 different derivatives. They have similarities and they have differences. Compare says what's the same. Contrast says what's different. So, free, shout it out, yell at me. What do they have that's the same? They all have an exponent. What's different about their exponents? Well, some of them are variables and some of them are numbers.
Yes.
Okay? They all have a base that is a single value. They all have an exponent that is a single value or variable. They all have different things in different places. Look at letter C. Look at letter C. I don't have any numbers. Okay, we're going to take these derivatives and then we will compare and contrast again. So first one. Oh, you're my favorite. This is just power rule, right?
Yeah.
4x to the third. Oh, nice and comfortable. Okay. This is our exponent rule. our exponent rule says we have 4 to the x, and then we have to take the natural log of the base. Okay. What about this? I mean, it's not, yes, we're going to have to power rule, but it's not, wait, no, we can't because it's, what?
Next to the
X times X. X
We-
times X to the X minus 1.
Wait,
Why not?
it'd be X. There's X there.
We don't have a rule for this, right? Like, I can't apply the natural log rule because the base is x, and I don't have a way to deal with that. So here's what we're going to do.
If you power rule it, you get X times X to the X minus 1, which is the X minus 1 takes it, is this, and you're multiplying it by an X, you're kind of like adding it back. You know what I'm saying?
Well, it says minus 1, so it doesn't work out.
So power rule only works when we have a numerical value in the exponent, and we have a variable in the exponent, right? And chain rule only works if what we have is an operation, like a function, that we know. And so we do not have any tools for this yet, except we do have implicit differentiation. So let's rewrite this as y equals x to the x. In order to get x out of an exponent, that's exactly why logs were invented. We invented logs, mathematicians invented logs, to deal with exponents. So let's take the log of both sides. The natural log of y equals the natural log of x to the x. Is this legal? Yes. As long as I'm doing the same thing to both sides of the equation, totally legal. Grace.
Why don't you just do the natural log?
Because I have, why? Why? Come look over here. Why would I choose natural log instead of log base anything?
Shorter.
It's shorter. It's less work. Natural log is 1 over x. Everything else, hot mess. Right? So I'm picking the one that's going to be easier for me. Could I do log base 10? Sure. But natural log is prettier. Okay, so now let's do something with this. Natural log of y is going to hang out for a minute. I'm going to bring out my exponent, right? This is still legal. Okay, now let's take the derivative. I got rules for taking this derivative. So I'm doing d dx of both sides.
You said that like dx is sort of like a unit, right?
It's not a unit, it's an operation. It would be like taking the natural log of both sides, squaring both sides, taking the square root of both sides, take the derivative of both sides. D dx is an operation. It's like adding 2 on both sides. Okay, so the derivative for natural log of y, we're going to have to chain rule it. So we get 1 over y times the derivative of y, dy dx. That you could think of, it's kind of like units. And then the derivative, now this is a product rule. So we're going to do the first times the derivative of the second plus the second times the derivative of the first. So dy dx. I'm saving this 1 over, well, actually, what am I going to do with that 1 over y? Let's multiply both sides by it, y. So dy dx equals 1 plus the natural log of x times y. What does y equal?
X to the X.
What?
Is that what we're supposed to do for like the test?
Yeah, so the one that said find the second derivative in terms of, I think it said in terms of y only or x only, I don't remember what it said. You are supposed to replace part of it with an equivalent expression. So I was able to replace y with what it equals, and this is my final answer. Done. I could distribute, but I don't have to.
That's not.
Okay. Are you ready for a break? Don't worry, we got more notes. We'll be back at it in a minute.